Hello viewers, my name is Damilare. In this lesson, we'll be looking at the topic metals, but we'll be focusing on calcium and aluminium. To start with, looking at calcium, it is very reactive. If you look at the group it belongs to, that's group 2 on the periodic table, very reactive. And we can find it in some compounds like calcium trisulcarbonate 4, which we can call limestone, or aragonite. And this limestone or aragonite, we can use it for making cement, chalk, marble, calcite. You can use the Ca to remember the calcite, and the other C to remember chalk. So that's for the first compound of calcium. Then another one is calcium sulfate, CaSO, for calcium sulfate, which is called anhydrite. That anhydrite means there is no water there. Anhydrite, so calcium sulfate anhydrite. So from the SO4, it means we can use it to prepare or to make H2SO4, that's acid. Now the third one is CaSO4 does 2H2O, which we call gypsum. So as you can see, this one has water compared to the other one that does not have water. The one that does not have water is called anhydrite, but the one that has water is gypsum. You can see someone that is inside the jeep is taking water, so that's calcium sulfate dihydrate. You can use this for POP. The POP, when someone is having fracture, that's bone problem, there is one thing that looks like clothes, white, that is used to tie that leg, that's POP. The same thing when you look at those that are building, all these builders, they also make use of POP as a finishing of their building to make it more attractive. So that is another compound of calcium. Number 4, we also have the one we call dolomites, that's calcium trisulcarbonate 4, then magnesium trisulcarbonate 4. So these are two compounds joined together as dolomites. So looking at these dolomites, they can be used to make glass, for making glass, and also concrete materials. That's looking at the calcium carbonate, magnesium carbonate, which we call dolomites. Then another compound of calcium, we have fluorspar. When you look at fluorspar, that's CaF2. You can use the F to remember fluorspar, calcium fluoride. So you can use this for making hydrofluoric acid, HF. The way we are using CaSO4 for H2SO4, we can use CaF2 for HF. So calcium fluoride to make hydrogen fluoride, so, or hydrofluoric acid. So that's fluorspar. Then even when you look at when you are extracting calcium, if you want to extract calcium, you can use that same calcium fluoride to lower the melting point of calcium chloride. As you can see it here, when extracting calcium, you get calcium chloride, but the melting point is too high. So if you add calcium fluoride, it will lower the melting point. Apart from fluorspar, we also have another one, which is calcium tetraoxophosphate. This is used in bones and teeth. That means it's strengthening the bones, strengthening the teeth. So you can give it a short name, BPL. That's bone phosphate lime. Because like calcium represent bone, the phosphate, that's a PO4. Then lime, calcium is also a lime product like limestone. So bone phosphate lime. Another compound of calcium, we have calcium oxide, which is known as quicklime. So this quicklime can use it for pH. That means to maintain the pH of a substance. Maybe it's acidic, try to lower it. By the time you add calcium oxide, so the acidic nature will reduce to a basic nature. You can also use it for cement. So that is for the quicklime. Then number 8, another compound of calcium, we have calcium hydroxide, which we call slake lime. This can be used to soften our water. When you have hard water, add it to it, it will reduce the hardness. That means hard water will not allow your soap to form ladder, that means to film. So but by the time you add calcium hydroxide, it will reduce that hardness. Then number 9, we have calcium chloride as another compound of calcium. So this can be used as a dehydrating agent. Maybe you take a substance that has water, so this will dry the water for you, that's calcium chloride. And it can also be used as a preservative, something that if a particular substance will get spoiled, it means maybe there is water coming out of it. So mean that calcium chloride will be drying the water so that it can preserve that substance. And it can be used to de-ice, that means to prevent icing of substance. So it can be used to de-ice substance since it's always against water. Now How do we now extract calcium? Because you don't see calcium alone. Right from the time when I explained metals in the previous video, so we have said that most of the metals, they are found as ore. They are together with another element, so we have to extract them from that ore. So if you want to extract calcium, just get calcium chloride. Once you get your calcium chloride, take note, the melting point of calcium chloride is high. It's like 750, but you have to add calcium fluoride so that it can lower the melting point from 750 to 650. And once the melting point is lowered, automatically the conductivity will increase. That means it will allow energy to be well managed, so it can conduct good electricity because we have lowered the melting point, so it will increase the conductivity. And what are the materials you will use for the electrolysis of calcium? So you need your graphite as your anode. So you can use angry to remember, an for anode, gr for graphite, angry. Anode is your graphite. Then you can use your iron as your cathode. You can say cat and iron, like cation, cat as iron. So it means your cathode you use iron. So this is the iron at the center, while this is the graphite under it. Why this one that is shaded represents your electrolyte, which is the fused calcium chloride, where you want to extract your calcium. So, and take note, electricity must pass through this the electrolytic cell, so that it can split the electrolyte calcium chloride, so that calcium can come out of the cathode, then the chlorine as a gas will come out of the anode. So that is how to extract calcium using electrolysis. Then physical properties of calcium, because when you see calcium physically, it appears as silver or gray, silvery gray color, and it's solid. As we have said about metal, their specific gravity is 1.55 gram per cm cube. They are malleable, that means you can hammer them, and then they are ductile, you can draw them into wire. Their melting point is 842 degree centigrade. Then they are good conductor of heat as a metal, also good conductor of electricity. What are the chemical properties of calcium? Chemical properties means when you add this calcium with another chemical substance, what will happen? Here we are adding calcium with a chemical element, oxygen, to form calcium oxide. If you also add water to the calcium oxide, it becomes calcium hydroxide. If you also add carbon dioxide to calcium hydroxide, it becomes calcium carbonate and water. And that's to tell us how reactive calcium is. Then we can also directly add calcium to water instead of going through the process of oxygen first before water. You can add it directly. You will still get our calcium hydroxide and hydrogen gas. That same calcium, we can add ammonia, just like ammonifying your calcium. When you add ammonia, it means the calcium will just pick the nitrogen and form calcium nitride, and the remaining H will be left out. Now, calcium can still be added with some non-metals, especially the halogens. So when it adds with halogen, it will form halide. And when you talk of the halides or the halogen, we are referring to chlorine, bromine, fluorine, iodine, all those halogens. So for example, now if I take calcium with chlorine, that's calcium chloride; with fluorine, calcium fluoride; with iodine, calcium iodide. So it means calcium can add with all these halides to form the halides of that calcium. It can add with other non-metal like sulfur, hydrogen, nitrogen, and so on. So with sulfur, it will form calcium sulfide; with hydrogen, calcium hydride; with nitrogen, calcium nitride. So that is how it reacts. Then another thing is that it can react with acid. Remember that when a metal is added to acid, it will liberate hydrogen gas. Then you also have your calcium chloride. Then it can also act as a reducing agent. Remember, it's a metal. Metal always give out electrons. So it means any substance that receives that electron that is donated by calcium, that substance will be reduced. So it's a reducing agent. Then looking at extraction, when you want to extract uranium from uranium tetrafluoride, UF4, when calcium is added to it, calcium can bring all this fluoride to itself and become calcium fluoride, while uranium will be left alone. So meaning that it has extracted uranium from uranium tetrafluoride. Also, it can act as impurities. If calcium should mix with your petroleum, it can corrode, cause corrosion. That means that passage, the pipe through which petroleum is passing, can begin to corrode because of the presence of calcium. So that is that on calcium. Finally, we want to look at aluminium, the second aspect of metal. So what can we say about aluminium? The first thing is the source. Where can we get aluminium? Aluminium can be gotten from a bauxite. Bauxite is Al2O3.2H2O. That's aluminium oxide dihydrate. So from this bauxite we can get aluminum, as you can see Al there. So they also from kaolin, that's aluminum trioxide dioxosilicate. So we can also get aluminum from this kaolin, as you can see Al is present there. Also from cryolite we can get aluminum, as you can see Al is there in cryolite. So Na, you can just say NaF, so sodium aluminum hexafluoride. So you can get aluminum from cryolite. Then also from mica, MiCe, so K2OAl2O3 6SiO2, we can get aluminum from this mica. So if you combine the four of them together, you can use the mnemonic CMBK, like comb. We want to comb the hair of the king, comb. So that's C for what? Cryolite, M for mica, B for bauxite, and K for kaolin. So we can get aluminum from all this. Now, how do we extract aluminium? If you want to extract aluminium, remember it will be from an ore. So we have to purify that ore that has impurities. So the ore is bauxite. So use hot sodium hydroxide solution. Once you add this hot sodium hydroxide solution to that ore of aluminium, so it will help you to treat all those impurities. Then you can filter off the impurities. Then we can take it through what we call electrolysis. So whereby in the electrolytic cell you will add the electrolytes inside the electrolytic cell. Then you put your anode and the cathode. So, and take notes, this is what we'll be using. We'll be using cryolite, 60% of cryolite. Why? Because we want to use it to lower the melting point of that bauxite, because the melting point of the bauxite will be too high, so without this cryolite. So that's why once you put your bauxite, add 60% cryolite to lower the melting point from 2000 to 1000. Then also add 20% of fluorspar. So these two things will be added so to help in electrolysis. Take note, what are the things we use in this as our electrolytic materials? We have the anode. Anode will be used as graphite, like I said, angry, and from anode, gri from graphite. Then cathode will be iron. Your cathode made of iron, from cation. So that's what will be used. So when you use your bauxite, aluminium oxide, at the end, the oxide, which is the oxygen, will come out from the anode. Then the aluminium from the bauxite will come out from the cathode, so meaning that you have extracted your aluminium. Now, physical properties of aluminium. When you see aluminium physically, it is silvery white in color. It's a metal, it's soft, it's ductile. You can draw it into wire. It's malleable, you can hammer it. It's moderate, it has a moderate tensile strength. That means it can withstand pressure, stress. When you hammer it can bear any stress. So that's moderate tensile strength. It's a good conductor since it's a metal of heat and electricity, meaning that electricity can pass through it, it can generate it. Then the melting point is 659 degrees centigrade, and the boiling point is very high, 2056 degree centigrade, and the gravity is 2.7. So the chemical properties of aluminium, that means when you hear chemical properties, it means when you add it with another chemical substance, what will be the reaction? So aluminium can react with oxygen to form aluminium oxide. So that's oxidation. Then, or let's say combustion, not oxidation. So adding oxygen to aluminum, just like combustion, to give aluminum oxide. It can also react with non-metals, especially halides like halogen. So it means, for example, if I take our halogen, chlorine, bromine, iodine, fluorine, so aluminum will form aluminum chloride, aluminum bromide, aluminum fluoride, aluminum iodide. It can also react with other non-metals like sulfur, nitrogen, phosphorus, and carbon to give us aluminum sulfide, aluminum nitride, aluminum phosphide, aluminum carbide. So it can react with non-metals. It can also react with acid, especially concentrated HCl. And remember that whenever metal comes into acid, it will liberate hydrogen gas, and that's why this H will come out as hydrogen gas, while aluminum will join with chlorine to form aluminum chloride. Then aluminum can still react with sodium hydroxide and water to give a large compound called sodium aluminate. Sodium is the Na, the aluminate is the remaining thing we have here. So this sodium aluminate, they can use it for paper, to make your paper very thick. Then also for detergent, so that it can cleanse your dirt. Then also for water treatment to coagulate all the dirty things. So that's what we can use sodium aluminate for, produced by aluminium in sodium hydroxide and water, and hydrogen gas will also be liberated. This same aluminium, we can add it with iron oxide, that's iron 3 oxide. Remember, iron 3 oxide it has been oxidized, so meaning that aluminium can reduce that oxidizing iron 3 oxide. So this is an oxidizing agent, but aluminum is a reducing agent. It can reduce aluminum oxide to what? Iron oxide, iron 3 oxide to iron, by removing the oxygen to leave iron. So it shows that it has reduced it. So we are also looking at the uses. What can we use aluminum for? Aluminum can be used as an alloy. That means you can mix it with another metal to form alloy. So the name of the alloy is called duralumin. Duralumin is made up of both aluminum, copper, magnesium and manganese. You can remember this from the name duralumin. Al is the aluminum, then the min means both manganese and magnesium. So from the Im, min, manganese and also magnesium. Then also this aluminum can be used as aluminium bronze. You know, bronze is copper and tin, but this one is now copper and aluminum, so that's aluminium bronze. Then also has a magnalum. Magnalum means magnesium and aluminium, so it means aluminium and magnesium will give us magnalum. You can use it for ship and also aircraft, all those light materials that doesn't need to be heavy, so like ship, aircraft, also moving parts of machines. You know, those things that will be moving in machine should not be too heavy, so that it will be easy for it to move it. So it can be used as moving part of machine due to strength, because aluminum is strong, and also hardness, it is hard than pure aluminum. So because another thing is that it's very light and it is resistant to corrosion. It will not allow corrosion, it will not allow your substance to corrode easily. So that's why they can use it to make most of those materials. Then they can use it to make pots, to make kettles, because it's very cheap and it's light and it's a good conductor of heat, meaning that if you are trying to heat something, maybe you want to boil water, so it can easily help you to boil your water. Then also for overhead electrical cables, all these cables they use for power and electricity, so the aluminum can also allow the electricity to conduct. So because it is light and also is a good electrical conductor, they can use it as a foil for package. Maybe you want to package your food, so you can easily use it to package your food because it's light. Then we also look at compounds of aluminum, which is the last thing. So aluminum can be found as aluminum oxide compound, and this aluminum oxide compound can be used for chromatography, that's color separation, or catalytic cracking, trying to crack those hydrocarbons that are very large. So you put it as a catalyst to speed up the breaking, so that it can break this higher hydrocarbons to a lower one. Then we also have aluminum hydroxide, is another compound of aluminum. So this will help dye stick to clothes. Maybe you have added dye to your clothes and you want that dye to be stable, you add aluminum hydroxide to do it. Then aluminum chloride can be a catalyst in organic reaction. For example, when you are cracking your higher hydrocarbon, you want to do isomerism, that means forming a higher compound, trying to change the form so that it can be in another form. So you add aluminum chloride. Then we can also use aluminum hydride, mix it with lithium hydride to form lithium tetrahydroaluminate, which is our common reducing agent. So the aluminum hydride from here, then another lithium hydride from here, we form lithium tetrahydroaluminate. Then the last one we look at is aluminum tetraoxosulfate 6. So this can combine with other sulfates. Remember, there's a compound we call double salt, which has 2 cations and 1 anion. So the first cation from this aluminum sulfate will join with another cation, maybe potassium sulfate. So aluminum and potassium, they will come together, while the sulfate will combine to form the double salt. So this is the double salt is called alum, so which is commonly used for water treatment to coagulate dirty things. So that's alum, to treat water and sewage, and also for paper making, e.g. the potash alum. So thanks for listening.